Okay, let's continue with 35. Number 35 asks us to find the limit as x approaches 0 of 3 sine 2x over x. Now if I fill in 0, I get sine of 2x equals 0. So that'll give me a 0 in the numerator and a 0 in the denominator. When I get 0 over 0, it means there's a hole in the graph and there's more I can do. Now hopefully you've memorized your special trig limit. The one that says that the limit as x approaches 0 of this function, sine x over x, equals, what is that? 1. Now, I showed you in class how we prove that with the squeeze theorem, but really, you just want to remember this limit. It comes up a lot. So, if we approach from the left and the right, we can see that this function goes to 1. It's not something that you could easily figure out. If I just gave you this, algebraically this would be difficult to figure out, or even with your trig rules. So it's one that you want to memorize, that the limit as x approaches 0 of sine x over x equals 1. You can see from this graph, this limit only applies to 0. The limit at any other place in this graph can be found by plugging in a value. But since the graph is not continuous at x equals 0, we need to use this special limit. Now if we look back at the problem we were given, we weren't given sine x over x, but we were given x is approaching 0, and we did get 0 over 0, which means we're going to have to find some way to work this, so sine x over x seems like our best choice. And we can do this simply by splitting this equation into some pieces. So let's say that it's the limit as x approaches 0 of 3 times sine 2x over x. Now that special limit also works if there are any number of x's here as long as they match. It changes this graph a little bit. It's always approaching 1. So if we had 2x over 2x or 3x over 3x, we'd still have a limit of 1 here. So we have 2x. If we simply add a 2 in the denominator, then we could use the special limit. So we need to multiply the numerator and the denominator by 2. So that's going to work because we can just move this 2 over here and we get sine 2x over 2x. And then this 2, let's move it over here. So we get 6 there. And as you can see, if I were to simply cancel out terms, I would get exactly what I started with. So all I've done so far is I took this 3 and pulled it out, and I multiplied top and bottom by 2. So now I'm ready to proceed with my limit. The limit as x approaches 0 of 6 is 6. Limit of a constant is a constant. The limit as x approaches 0 of sine 2x over 2x is 1, because we know that from our special limit. Our answer is 6. Number 36 asks us to look at one that involves our special cosine limit. So for this problem, we would want to know about the special cosine limit. So the graph of 1 minus cosine x over x, pretty cool looking graph actually, but as this graph approaches 0, we get 0 over 0, right? Because 1 minus cosine of 0 is 0, and of course you'd have a 0 in the denominator. So we have a hole in this graph also. It's also kind of a long proof, but you can see by looking at the graph that this limit is 0. So that's another one to memorize. The limit as x approaches 0 of 1 minus cosine x over x equals 0. So that's another thing to memorize, because it's not one you can really figure out on your own in a test situation. So when we plug into this problem, we get 4 minus 4 cosine of 0. Do you remember that cosine of 0 is 1? So we get 4 minus 4 in the numerator, which is 0. And we get 3 times 0 in the denominator, which is 0. So we get 0 over 0. So we know there's more work to do here. And since this looks a little bit like our special limit, let's see if we can make it look exactly like the special limit. So what if we factored a 4 out of the numerator? That gives us 1 minus cosine x over 3x. So we have a different number of x's here, don't we? If we can get this 3 out of the way, then we would be ready. So let's do this. Let's say that it's 4/3 times 1 minus cosine x over x. And I should have continued my limit notation here. And you can see that's legal. If I distribute all this out, I have exactly what I started with. Now we're ready to use our special limits. The limit as x approaches 0 of 4/3 is simply 4/3, because the limit of a constant is always at that constant. And the limit as x approaches 0 of this is our special limit. That's 0. Our answer is 0.